everyone. In today's class, let us discuss about de Broglie's hypothesis of matter waves. So, in Newton's time, matter and radiation both are assumed to have particle nature or consist of particles. With the discovery of interference, diffraction and polarization, it was known that light is a kind of wave motion. In the beginning of 20th century, a new phenomena such as photoelectric effect, Compton effect, etc. are discovered. Now these effects cannot be explained on the basis of wave theory. So these are explained on basis of quantum theory, right? Now if we apply photon theory to explain interference and diffraction, it is impossible to explain this interference and diffraction based on photon theory. Okay, we cannot explain this based with the help of photon theory. So from this, it is understood that here the light has dual nature. The light has dual nature. So dual nature means the light has particle nature as well as wave nature. Then when we explain this interference and diffraction on base of photon theory, then what happened? They failed to explain. They failed to explain interference diffraction based on photon theory. Why means? Actually, when light is having dual nature, that is particle and wave nature, they must explain this interference diffraction based on photon theory. But here, they could not explain. Why means? When some particular particles have the properties of wave nature only, right? And some particular particles have the property of particle nature. Means in a nature, some particles will show or wave nature will dominate compared to the particle nature. In some substances or particles, particle nature will dominate compared to the wave nature. So now this wave nature and particle nature totally depends upon the conditions under which a particular phenomena occurs. Okay. So these both never occur simultaneously. If we study about particle nature, wave nature will be hidden. If we study about wave nature, particle nature will be hidden. Means simultaneously we cannot study about particle as well as wave nature. Okay. So here light has dual nature, particle and wave. When we concentrate on particle nature, we cannot see the wave nature. When we concentrate on the wave nature, we cannot study about the particle nature. But light has dual nature, that is the wave as well as particle nature. So in some 1924, Louis de Broglie, he extended this wave particle parallelism of optics to all fundamental entities in physics. Means he applied this dual nature to electrons, protons, neutrons, atoms, molecules, etc. And he said that not only the electromagnetic radiation, that is radiations, will have dual nature, but along the radiations, like radiations, even the matter has dual nature. Matter has dual nature, not only the radiations. Like radiations, even matter also have dual nature. That is, dual nature means it has particle nature as well as wave nature, both it will have, right? So now he said that a moving particle, such as this is a particle. A moving particle is associated with a wave. He said that a moving particle is associated with a wave. Okay, and these waves he called it as de Broglie wave. These waves he called it as de Broglie wave. And the wavelength of this matter is given as lambda is equal to h by mv. The wavelength of this matter is given by lambda, where it is the wavelength h, Planck's constant. Okay, m mass of the particle, v the speed or velocity of the particle. Speed or velocity of the particle. So according to de Broglie theory, every particle, moving particle, is associated with the wave, which we call it as de Broglie wave, and the wavelength is lambda is equal to h by mv. Right? Now next, let us find some expressions related to the de Broglie wavelength. Okay, now some expressions for de Broglie wavelength. So first, we know that energy of a photon is h nu, where nu is the frequency, right? We know that C equal to nu lambda. So in place of nu, I will substitute C by lambda. Okay. So E equal to H C by lambda. Okay. And now, according to Einstein relation, E equal to M.Sc square. Right. So now from these two equations, we can write M.Sc square equal to Hc by lambda. C strikes off, so lambda become H by mc, where mc is nothing but momentum, mass into velocity. So we can write hp. Okay. So now momentum, this is nothing but momentum associated with a photon. Okay. Now next, if E is this is one form of de Broglie wavelength. If E is the kinetic energy, then what we will write? Half mv square, right? Or I can write this equation as half m square v square by m, or half m mv whole square. Mass into velocity, nothing but momentum, p square by 2m. So from this, p square can be written as 2me, right? And now p can be written as momentum under root 2me. Okay. Now next, what is lambda? H by p, no? So we can write instead of p under root 2me. This is the another form of de Broglie wavelength in terms of kinetic energy, with m as mass, h as Planck's constant. Right? Now next, let us go for another form. Okay. Now, if a charged particle carrying charge q is accelerated with a potential difference v, then kinetic energy is written as qv. Right? So now only we got the equation as lambda equal to h by under root 2me. So lambda becomes h by under root 2m qv. Okay. This is another form in terms of potential difference. De Broglie form in terms of potential difference. Now next step. When a particle is in thermal equilibrium at temperature T, then E equal to 3 by 2 kT. Right? Now lambda equal to h by under root 2me. Okay, that is equal to h by under root 2 me 3 by 2 kt. I substituted in place of e, so 2 strikes off, so lambda becomes h by under root 3 m kt. This is in terms of temperature, de Broglie equation in terms of temperature. Now similarly, let us see the de Broglie wavelength associated with electrons. De Broglie wavelength associated with electrons, right? So now if m naught is rest mass, okay, e the charge accelerated by potential v volts, accelerated by potential v volts, right? Then the kinetic energy is written as half m naught v square in terms of rest mass, and in terms of potential difference and charge we will write it as ev, energy. So half m naught v square equal to ev, right? Now here we can write v equal to, now this is capital V for potential, v square equal to 2 ev by m naught, or v equal to under root 2 ev by m naught, right? Now next we know that lambda is equal to h by m naught v. So h by m naught, what is the value of v? 2 ev by m naught, right? And now let us write as h root m naught comes in numerator by m naught under root 2 ev. So h by, here one root m naught will remain, m naught, root m naught will cancel, one root m naught from here it will cancel, root m naught will remain, so 2 m naught ev we can write. Now Planck's constant value is 6.625 into 10 to the power of minus 34 joule second under root 2 into the rest mass of electron is 9.1 into 10 to the power of minus 31 kgs, and the charge of electron is 1.6 into 10 to the power of minus 19 coulombs, and let us convert into volts, it becomes minus 10, okay, and let us write volts. So let us keep in coulombs 10 to the power of minus 19. So now if we go for the simplification, we get 12.26 by root v angstrom units, okay. If v equal to 100 volts, then lambda becomes 1.226 angstrom units. So this equation shows that the wavelength associated with an electron accelerated to 100 volts is 1.226 angstrom units. So de Broglie wavelength in terms of potential difference is 12.26 by under root v angstrom units, right? Now next, so in such a way the de Broglie wavelength is h by mv. So this is the important formula for solving the problems. Not only this, the de Broglie wavelength h by under root 2 mqv. So lambda is equal to h by under root 3 mkt, or lambda is equal to h by under root 2 me, or lambda is equal to 12.26 by root v. So these all are useful for doing the problems in entrance exam. So note down these formulas. So what parameters he asked, whether mass, temperature, and what he is asking to find. Depending upon that, just use that particular formula and do the mathematical part. Thank you.